Ladies and gentlemen, it's a great pleasure that I welcome you here at SCOR's headquarters to this international and scientific seminar. And as you know, we're going to discuss throughout the next 2 days the topic of decision-making and insurability in the context of climate uncertainty. The seminar is co-organized by the Toulouse School of Economics, the Geneva Association, and the SCOR Corporate Foundation for Science. These three institutions have worked very closely together in order to gather climatologists, economists, modelers, actuaries, and insurance and reinsurance industry professionals with the aim of making an hopefully innovative contribution to the general reflection on climate change. This year is indeed quite special for us in Paris, since, as you know, France has been officially appointed the host country for the 21st Climate Conference, the famous now COP21, with higher stakes than ever before. I truly hope that this seminar will generate scientific exchange that will continue throughout 2015, and alongside the many events organized in the context of the 2015 Paris Climate Conference. May I cite notably AXA. AXA is organizing an important seminar, the 3rd of July, entitled New Rules for New Horizons, Regulating Finance for Sustainability. And Christian Thiemann is with us, and please liaise with him if you are interested to attend. The SCOR Corporate Foundation for Science was created 4 years ago in 2011 as part of SCOR's long-term commitment to risk research. And the foundation has developed various partnerships with universities around the world in such disciplines as mathematics, actuarial science, climatology, economics, and finance. And it is chaired by André Lévy-Lang here at the first row. Thank you, André, for chairing this foundation. The Toulouse School of Economics, TAC as we name it now, absolutely famous for its contributions to the improvement of economic decision-making, has long been developing research on environmental issues, including the economics of natural resources, the evaluation of public policies, and the political economy of the environment. The Geneva Association, as a leading international think tank of the insurance industry, was created back in 1973, but began its research into the field of extreme events and climate risk in 2008, with one focus being the role played by insurance in the reduction of disaster risk. The Geneva Association made a very important statement for me. The 29th of May 2009, we were in Kyoto, and we called it the Kyoto Statement, to define the role and the implications of the insurance industry facing climate changes. I brought copies of this statement for those interested. It's only a couple of pages, so you have no excuse not to read it. And the Geneva Association then established a working group of experts on extreme events and climate risk, chaired by Michael Butt, and Michael Butt here is the 3rd row, from Axis, and Shuzo Sumi, who is the CEO at the time, now chairman of Tokyo Marine. May I pay tribute to Michael Butt for his relentless efforts to push insurers and reinsurers to address the issues of climate change and extreme events, but not only to address the issues, but also try to provide solutions in order to contribute to the consequences of those climate changes. I have the pleasure of co-chairing now this working group with Shuzo Sumi. And 2 months ago, the Geneva Association and Tokyo Marine with the UN held a seminar in Sendai City in Japan on disaster risk reduction, insurance as contributors to problem solving and impact reduction. So it was only natural to bring these three institutions together in order to invite high-level researchers and industry professionals to explain how research and science can give us a better grasp on climate risks and their insurability, notably through forecasting and modeling. Let me give you a quick flavor of the key issues we're going to discuss throughout the 2 next days. Today is going to be dedicated to the modeling and forecasting of climatic events. During a first session on climatology this morning, André Lévillan, Valérie Masson-Delmotte, Sonia Seneviratne, and Antoine Flao will give you an overview of the current state of knowledge on climate change and climate risks at different timescales. This afternoon, during a second session on climate risk modeling, Claire Souche, Anthony Davison, Philippe Navo, and Nicolas Trèche will guide us through the modeling of climate risk and natural catastrophes in the context of a changing climate. The session will be concluded by a roundtable of NatCat modeling with Aman Shah, Jay Gwynn, Dickie Whitaker, and Lyndon Patton, and moderated by Paul Nunn being the big guy for risk modeling at SCOR. Tomorrow will be dedicated to decision-making and insurability in the context of climate uncertainty. In the morning, in a session dedicated to economics, Christian Gaulier, Simon Dietz, Geoffrey Hill, Charles Kohlstadt, and Robert Pindick will tell us how economic science can help us to make rational and sound decisions in a context of climate uncertainty. And finally, tomorrow afternoon, during a fourth session on policymaking and climate risk insurability, Otmar Edenhofer, Erwan Michel-Kerjean, and George John will focus on insurance and economic resilience. The session will be concluded by a roundtable on climate risk insurability that will bring together Simone Ruiz-Vergot, Victor Peignet, Pierre-André Chiappori, Christian Timan, Maazaki Nagamura, and Peter Hope, with Mariam Golnaraghi as moderator. I would like to take this opportunity to extend my warmest thanks to all these high-level researchers and industry representatives for participating in this seminar and for making this program possible. Let me now introduce, because you were not here to listen to what I say, but for another reason, which is just next on my right, let me now introduce the great, the rigorous, the influential winner of the 2014 Nobel Prize for Economics, Jean Tirole. I'm proud to say that SCOR has been a supporter of Jean Tirole, may I say, and the TSC researchers for several years, with two research chairs that we finance, the first one on market risk and value creation, and the second one on finance. These chairs have enabled TSC, Toulouse School of Economics, to conduct outstanding theoretical and empirical research into risk and have given rise to numerous publications in the best international academic journals. At the beginning of the 90s, Jean-Jacques Lafont, a common friend of us, Jean and myself, sought my assistance to develop the Institut d'économie industrielle, which was at the basis of the Toulouse School of Economics. We were back in the early 1991, 1992, which he had just created with the aim of attracting top researchers. In this context, the FFSA, of which I was then the chairman, awarded a research chair to Jean-Jacques Lafont in 1992. That's quite a long time ago now, thereby enabling him to attract and retain at Institut des études industrielles brilliant young talents, among whom the brightest and most promising was Jean Tirole. Jean Tirole is one of the most quoted economists in global economic research. His work deals with an extremely wide variety of economic areas, and he has published a very large number of scientific articles in the most prestigious international academic journals. I'm very proud that Jean Tirole agreed to become a member of the scientific board of the SCOR Corporate Foundation for Science in 2012. It has been a great pleasure to continuously benefit since 1992 from his insightful, stimulating, and innovating research, which has played such a decisive role in our understanding of risk, finance, and principal-agent relations. Today, Jean will present you the conclusions of his latest research on effective institutions against climate changes in order to tackle the free riding issue generated by the lack of collective action in environmental matters. Without further ado, ladies and gentlemen, please welcome Jean Tirole.
Well, thank you very much, Denis, for those very kind words. And I must say we have been very pleased to collaborate with the SCOR for quite a number of years. It's very important that they've been very supportive of our research without interfering in it and giving us their insights. So, we can find new research topics, very relevant ones, and that's a model of collaboration, I think, between industry and academia. So we are very grateful, and very grateful, of course, to SCOR for hospitality today, grateful to the organizers, and grateful to all of you for coming. Thanks so much. It's going to be a great conference, I think. So today I would like to discuss climate change and just as I know that's not the one. So how do I get into?
Tournant comme ça, vers vous.
Okay.
En la tournant vers vous.
Ok. Et après je appuie là. Non.
Il faut la poser la souris.
Non.
Voilà, c'est là.
Okay.
C'est celle-là. C'est celle-là pour.
So much for my abilities. Okay. So it's joint work. Christian Gollier actually will have a paper in about a week from now, pretty long paper stating all our conclusions. So if you want it, probably it will be on our website or something. We are very worried, to be honest, because we have been living through that game for now 20, 25 years. Kyoto was a big failure. Copenhagen was also a very big failure. And what was striking, I remember I wrote a report for the Council of Academic Advisors like 6 years ago, was a striking contrast between a very ambitious targets, basically trying to be in conformity with the IPCC objectives, and the extremely modest commitments, not even commitments for 2020. And my view is that Copenhagen will fail. It actually didn't bring the waiting game to a halt, and we have to ask what are the implications, what should be the roadmap for COP21 in Paris. So the learning curve, okay. So as you all know, Copenhagen basically decided to abandon the idea of carbon pricing and to rely on non-committal pledges. So the governments will basically pledge, have promises, and that was confirmed in Lima, and that's what's going to happen in Paris, unfortunately. But if you want to have some kind of international agreement, first you have to ask, can we check whether the promises are abided by? And you need two things, of course. You need one thing, which is reporting. I mean, it's very elementary, it's very basic. You need to send a satellite and try to measure how much pollution is created by various countries. So you need reporting and verification, which is not being discussed now. You need an enforcement. You have to ask, if you don't abide by your promises, what are you going to do, or what are we going to do? This is not being discussed. The idea of a binding agreement is still not in the air 25 years later. Then we have to ask, for an agreement to be credible, it has to be least cost, or at least not too costly, because otherwise it's going to fail at some point. But of course, if you have pledges by the countries, some countries will spend 100 euros to eliminate a ton of CO2, and some other countries will spend 5 or 10 euros. And of course, this is not least cost approach. And then there is a difficult issue, which is burden sharing. And as you know, in 2010, following Copenhagen, a green fund was established to transfer money to the less developed countries, 100 billion per year. At this stage, as you would expect, there are vague promises to 10 million in stock, not in flow, 10 billion in stock, not in flow. So the waiting game is continuing. Now, there is a big cost of delaying negotiations. I don't trust promises. I mean, we have seen many promises in various areas. Of course, you should not believe in them. And before a real agreement is reached, what will you get? Free riding. So when a country spends 100 euros to reduce, to eliminate a ton of CO2, it's going to get 1% of that in terms of benefit if its population is 1% of the world population, and the exposure to climate change risk is kind of average. So 1% benefit is very small. Actually, it may be much less than 1% because you have leakage. Leakage, you may have a shift of manufacturing to low carbon price countries. If you consume less fuel, for example, less gas, then it's going to lower the price of oil. And then, of course, because it lowers the price of oil, then other countries are going to consume more, so there's another leakage. The clean development mechanism in Kyoto, set up in Kyoto, also has leakage because, of course, if you, for example, save some forest here, then the price of food, the price of soil, the price of whatever you do when you deforestate is going to go up, and of course there will be more forest destroyed somewhere else. So leakage is a big issue. And finally, historically and theoretically, it's pretty clear that anytime you have a real negotiation, it's always the brown countries which get subsidies in some way from the green countries. They have to be bribed to get on board. So you don't have an incentive really to get green very fast because you are in the driver's seat in the next negotiation. So that's a real big issue, and that's exactly what you observe. Now, people who are proponents of pledge and review point at some voluntary actions. But we should be very suspicious of that. There are those actions. I mean, they do exist. But there are, of course, various reasons why they exist. I mean, the first is co-benefits. So, for example, if your power plants use coal, this coal is going to, of course, emit greenhouse gases, but also is going to emit SO2, NOx, and various acid rain pollutions, which are kind of local. And of course, those are fully internalized by the country. So even a country which doesn't care about CO2 will do something. Then there are some countries, of course, which are pretty big. So, for example, China is not 1% of the population, and furthermore, it's pretty exposed to climate change risk. And every government wants to placate public opinion at home and avoid international pressure. So we'll see some actions, but they will be what Robert Stavins calls zero ambition actions. In a sense, you know, the effort is basically what you do beyond what you will be doing just for a selfish point of view. So the metric is very hard to measure. You know, are those actions be 10, 20%, 80% of what people should be doing, countries should be doing? We have no clue. And by the way, as economists, we should be suspicious. There's a screening argument, which is a country which intends to abide by its promises has everything to gain from a binding agreement. The only countries who are going to lose from a binding agreement are the countries who just don't want to do it. Okay? So we should be very suspicious about all those things. The economic principles, we know them. They've been known for a century now. Imagine, this is not Paris, don't get your hopes up. This is not Paris. Imagine that we get an all-encompassing agreement. We would like to have price coherency, the law of one price, worldwide, identical for all sectors, and consistent over time. It's simple, it's efficient, it's least cost abatement, and that's what we should be doing. Okay? Now, instead of that, people tend to rely more on command and control. So for those of you who are not economists and don't know what command and control is, it's a set of measures which are going to induce a deviation from the law of one price. So emission standards, and let me just qualify here that emission standards may be attractive in some circumstances. And I'm not against emission standards, but simply that most standards actually don't rely on an assessment of the implicit carbon price. So they are kind of random. That's what I don't like about standards. But a well-designed standard actually can be, in some cases, quite good. Bans, subsidy to targeted sources of energy and whatnot. So just to illustrate the ideas, imagine that you have two firms. You could have two countries, two sectors, whatever, but two firms, and each firm emits 2 tons of CO2. So you have 4 tons of CO2 overall, and you would like to reduce pollution by half to 2 tons. Imagine that firm A has a cheap abatement cost. It costs only 10 euros per ton, to reduce the pollution, eliminate the pollution. Firm B has costly abatement. It costs 100 euros per ton. Now, imagine that you adopt a fair policy. So the government steps in and says, you're each polluting 2, you both reduce to 1 each. Okay? That's fair. That's completely fair. That's very attractive. However, the cost to society is 110 euros because for one it costs 100 euros, for the other one it costs 10 euros. We know what the efficient policy is. The efficient policy is Fermi should do the job. So Fermi, it costs only 10 euros per ton to reduce pollution, economize, and therefore the total cost will be 20 euros. So you see the huge increase in cost, and that's bad for society because it's costly, but it's also bad for climate because at some point, if it's too expensive, it's not going to work. People will quit the agreement. Now, to do it, there are various ways of doing it right. So, for example, you can issue 2 pollution permits in some way. For example, you give one to each firm, and then firm A will sell its pollution permit to firm B because there are gains from trade of 90 euros, 100 minus 10. More generally, what you want is a market price P. In the permits market, if you use a permits approach, or you could use a carbon tax approach, it's up to you. And then those with an abatement cost which is less than P will just reduce their pollution and not acquire the pollution permit. They will sell the pollution permits. And those with an abatement cost higher than P will acquire the pollution permits. And that way, that will be efficient. Okay, now, do you want to have a carbon tax or a cap and trade? So a carbon tax is just say, you have to pay 50 euros per ton of carbon. Cap and trade, you decide on a total number of permits, and then you have a tradable permits, a trade of permits among the parties. And then there is a market price which arises from that. So imagine that we know the pollution of firms, households, and administrations as a function of the carbon price. So we think it's downward sloping. So if the carbon price is higher, then the pollution will be lower. You can either use a tax. This is a blue, is that blue? Yeah, the blue thing. And once you set a tax, you know what pollution is going to happen. Or you can issue tradable rights, pollution permits, and let them be traded, and then the market price will be set, and those will be two completely equivalent policies. You can use one or the other. Now, in practice, there is a lot of uncertainty. So today, we can compute what. So, for example, imagine that you have the cap and trade approach. We say, here is a trajectory of emission which is going to give rise to 2 degrees Celsius. We don't want to go beyond 2 degrees Celsius. Here is a trajectory we want to have. Now, there is uncertainty, of course, because there's still scientific uncertainty about the speed of warming. There is a lot of uncertainty about the technology, about acceptability, and so on. So there is uncertainty, and whether you use a price or cap and trade will get it wrong. So in that case, that means that we will have to adjust. We'll have to adjust the price, or we'll have to adjust the number of permits. Actually, that's something we had been studied 20 years ago with Jean-Jacques Lafont. We asked what happens if there is uncertainty. So you learn over time that you make mistakes, and you learn over time. You can say, well, we can always adjust. But the problem with that is there's a time consistency problem, because if you want people to invest in carbon-free technologies, you must have perspective that the price tomorrow will be reasonably high, because otherwise you don't invest. Many investment in carbon-free technologies are not this year. They are going to have an impact over 10, 20, 30 years at least. So you need some kind of perspective on the carbon price, and if you let governments have no commitment, then so you need a formula, and we derive the optimal mechanism for that, and we could discuss that if you want. But the thing is that you have to be aware that we're going to make mistakes, and you must plan some automatic adjustment mechanism as part of the initial setup. Now, cap and trade has been used many times now. Sometimes it has been very well designed. Sometimes it has been a mess because people didn't understand how to design a cap and trade mechanism. But regardless, we know how to do it now. We know, the 5 or 6 features that you want to have, and we know what mistakes you want to avoid. So, the most famous one is CO2, but of course the CFC thing has been very prominent and so on, and we now have in many countries some kind of CO2 exchange. at very low prices, because now in Europe it trades at 6 or 7 euros per ton, which is ridiculously small. Now, this is an important slide. If you think about cap and trade versus a price, a tax, a carbon tax, economists are a little bit divided. I mean, to be honest, some people favor carbon tax and some people favor cap and trade. Christian and I favor cap and trade for political economy reason. And in our view, the basic issue with the carbon tax is the monitoring of compliance. To understand why there is an issue is the following point. Today, countries could impose a carbon tax. Any country can impose a carbon tax, and they don't, except Sweden, which has a 100 euros carbon tax, but the others don't. So they could impose a carbon tax, get the revenue from it, and they don't. And the reason for that is the reasons I gave you earlier: free riding, leakages, bargaining, future bargaining, and so on. So that's very predictable. They don't want to do it. Now, do you think that the day there is an agreement, then the countries will levy the carbon tax? Well, they might, but they might not. It's pretty easy to turn a blind eye onto some emitters, not spend much resources on enforcement. It actually can be costly to enforce at the local level. And, you may keep free riding by basically not enforcing the tax. Okay? And don't forget, it's a serious issue. When a country doesn't want to collect the tax, you have trouble. It's very not easy. Look at what happened with Greece. The troika is in the country, and nonetheless, it's very hard to make progress on tax collection in Greece. So there won't be any troika in the various countries, and we are worried, and maybe we don't know. It's just a guess that actually the countries won't collect the tax fully. Then they can undo the tax, and that's equally dangerous. Now, if the commodity or the service is subject to a VAT with a uniform rate, that's not a problem. But many times you have some excise tax which is specific. Think about the gasoline tax. In France, it changes all the time. Or heating oil or gas or whatever, or coal. You can basically undo the tax because you can levy a carbon tax at the same time, and you don't do it the same day. I mean, that would be stupid, of course, but you do it a bit later, and you reduce, or a bit earlier, and then you reduce the corresponding tax, and then you have not collected anything. The other issue with a carbon tax is that you have to put a price on everything. So, for example, if you decide, for example, that you want to insulate houses, which actually is a very important aspect, policy to reduce CO2 emissions, you want to use standards, and we could discuss why. You may actually want to use standards for that. But then, what is a price? So in a standard, you need to have an implicit price. And you may imagine that it will be highly contentious because the country will say the price is very high, the price of my standard is very high, and the others will say, no, it's low, and you will have a lot of debates about that. The other issue we see the carbon tax is that it's a uniform price. We think it's actually good from an economics point of view, we think it's a good thing. But lots of countries would like to have some flexibility. So India may want actually to keep the price of cement low, and it won't be able to do that under a carbon tax. I'm not saying it's a good thing, but there are political economy reasons for which you might want to go for subsidiarity. Now, all those things have to do with compliance. So I think, Christian and I think that actually a carbon tax is extremely hard to monitor and verify. Whereas with a cap and trade mechanism, it's very easy. You send a satellite, you measure the pollution of France every year, and you say to France, if you have enough permits, and you have too many permits, you sell them on the market. If you have too few permits, you buy some on the market. But we know exactly, it's much easier. Well, we'll have some scientists who will confirm that later on maybe, but it's much easier to monitor the pollution of a country than monitoring the pollution of point sources. So you just measure, you send a satellite, it's cheap, you measure pollution of countries and you make countries accountable. So it's very straightforward. There is no prime of enforcement. Let me start with subsidiarity, which I already mentioned. So we suggest setting up a monitoring system that at least tracks country emissions over time. And sure, the problem with subsidiarity is that it will lead to local deviations, so country-level deviations from cost minimization. But I would say it's the country's business. So if the country wants to have higher costs than it should, that's its own business, as long as, you know, the other countries care about how much France pollute. That's the only thing the other country care about. They don't care about whether we pollute, you know, through roads, housing, manufacturing. This is completely irrelevant to other countries. What matters is how much CO2 is emitted by France, okay? And as I say, you might want to get government on board. Let me say a word on burden sharing, and I will come back to burden sharing, and that's really a big thing and the most difficult issue. It's one thing to have gains from trade, and they are huge. You know, you have a single price, however you do it. But the question is, how do you get to share the gains from trade? That's the usual question in economics. And you need to have some kind of agreement to get all countries on board, because the countries are not symmetrical, so it's really hard to get them on board. So the solution found in Copenhagen is a green fund. As expected, the promises are extremely small at this stage. Now, historically, actually, this is not the way it has worked. You go back to 1990 with the SO2 agreement, the Clean Air Act amendment in the US. Basically, there was a huge subsidy from the East Coast, the West Coast, to the Midwest. I was in Boston at the time. I didn't read anything in the newspaper about these huge transfers that happened when the Midwestern state got free permits. That was a gift. No newspaper article, I may be wrong, some of you may have read those newspapers, but nobody talked about. Same thing when in Kyoto we gave lots of permits, hot air permits to Eastern Europe and Russia. I didn't read, I was in France at the time, I didn't read in France, you know, anything about that. Now, this is a very weak argument, to be frank, because a politician, in principle, they should be able to put a number. You give so many permits to this other country, this is how much we transfer to the other country given the market price. But it turns out that historically, actually, the cap and trade mechanism has been a much more discrete way of transferring money, you know, through the allocation of permits and a carbon price. Okay, it's a green fund or that kind of fund. And you see why, because, you know, if you tell a senator of Texas that the US is giving, you know, X to India, then you see what the senator of Texas is going to say. Now, that presumes, that's a dangerous argument, of course, I realize, because I don't want to, you know, for us to happen what happened to John Gruber in the US. For those of you who know the Gruber thing, poor John got killed by the Senate for having said things which are similar to this one. So I don't want to insist too much on this argument. And as I say, it has worked in the past. It's not sure that it will work in the future. Now, enforcing the argument, okay, this is also a difficult issue. So first thing, we need to enforce. Let's assume we have an agreement. We need to enforce. We need, you know, being excluded actually is wonderful for countries. You have nothing left to do. So you like to free ride. So being excluded from the agreement is not really a big punishment. It's like, you know, being excluded from a family you don't like. You know, oh, great. So, so you can, you know, one thing you have to do, of course, is that if you have a cap and trade mechanism and you give permits for 2030 or something like that, you don't give them immediately. You give them conditionally on good behavior so that you respect the agreement. WTO sanctions, so you can make a clear argument that low carbon price or the non-respect of agreements is dumping, and then you face WTO sanctions. I mean, we have to be careful. We have an international agreement that does something. We don't want to kill it, but we have very few degrees of freedom in enforcing climate change agreements. You can use naming and shaming. You should, but it's not going to work very well. And look, people have made promises in Kyoto and then have basically said we are not going to ratify it or we are not going to abide by the promises. And you always find good excuses. I mean, of course, there was a good excuse because others were not part of the agreement, but more generally, you'll find lots of, I'm doing effort somewhere else, or it's too easy. The last point is that you should monitor indebtedness. So let me explain. Imagine that France pollutes 110, and at the end of the year, it has only 100 permits and doesn't buy the 10, in which there is a shortage of 10, and doesn't buy them. Then you want this to become public debt. It's a climate debt, and therefore it should become public debt. Now, at what price? Well, the market price, because that's the amount which was economized by not buying the permits. So you have an easy way to compute the increase in sovereign debt, and therefore you should get the IMF involved. Okay. Let me. I would like to have some kind of time for discussion because I think that's very important. It is such a big issue, and we are so concerned about it that we have to brainstorm, and I look forward to your comments. Innovation is, of course, a big thing, and we also have to think about it. Green innovation is needed, of course. Just economizing and is not sufficient. We need to have green innovations. And of course, we economists will say we need a credible carbon price. So if you anticipate that the carbon price in 20 years or 15 years will be €5, then you won't get much green innovation unless it's subsidized by the states. But it may not suffice, especially for fundamental long-term research, so kind of research which will have a big impact in 30, 40, 50 years. And we need R&D subsidies and public support to green research if there are spillovers, of course. There is the same issue as with the carbon price, which is there is free riding. And there is the issue about having international consortia, because the location of top-notch research is not going to be random. We know where it's going to be. And of course, that means that different countries will benefit very differently from any international consortia. But we have got to face it. We need research. It's very important. It's very costly to systematically use all technologies to abate pollution. We need also extremely good research and green innovation. So on the compensation side, let me just say a few words, because that's really the hardest part. As I said, financial transfers are transparent and perhaps unrealistic. I hope I'm wrong. Maybe there's a slight advantage in terms of the allocation of permits. Now, who should be let's assume you have a green fund. Who should be the contributors? And then I think there is often a tension between ethics and realpolitik. Lots of less developed countries says we should have the same target of pollution per inhabitants. In a sense, they are right, and they are morally right. The problem is that if they hold to that stance too strictly, they are going basically to shoot themselves in the foot. Why? Because they are not in the driver's seat. I mean, I'm very cynical here, and I think there is a conflict between ethics and reality, between forward-looking and backward-looking policy. If you analyze the thing, who is in the driver's seat? The most reluctant countries to get on board. Those are the countries which pollute a lot, and the countries which are going to be little exposed to climate change risk. Now, if you correlate that with less developed countries, well, the correlation is not one, I would say. So there's an issue there. I think the rich country will have to be much more generous than they are now, but I also think that the poor countries have to pay attention because they might not get the agreement, and they will be the ones who are going to suffer the most. And that's a worry, and we have to be realistic at some point and make sure those poor countries are not going to suffer so much. And I'm very worried that the current process is going to just deliver that outcome. Then there is another difficult issue, is whether you should bargain at 200 countries. And this is not my area of expertise. I kind of doubt it somehow. But it's only a guess, and probably some of you will have a reaction to that. You know, having 20 countries like the G20, basically negotiating an agreement, then through the WTO, putting pressure on the WTO to enforce some pressure on those who haven't signed yet, trying to get the other countries on board, might be more realistic. What do I know? But it's clear that there are limits to the process. We have known it so far. Now, don't get depressed after this talk. What should we do? I mean, you know, when you see what should be done, and when we stand now, 6 months from COP21, it's very, very depressing. It's incredibly depressing. So I think we have to be modest, but here's my conclusion from, and I know Christian shares it from 6 years ago. I said, we are not going to get it in Copenhagen, what should we do? And unfortunately, the same thing is still true today. So don't look for inefficient patches and cheap pledges. Agree on some short-term actions, and at least get the right framework. The right framework, we know it. We need a good governance, a path of CO2 emissions. The scientists will tell us what this path is. They know it. There is some uncertainty, but fine. If you want to go for cap and trade, which is our preferred solution, but you can go for alternatives, that's fine, as long as that you get some economic instrument. You have a worldwide CO2 market. You want to have a good governance. So that's what I told you about with the WTO, the IMF, carrot and stick, and so on. You go back to the basics. You send immediately a satellite emission, independent satellite emission tracking systems. You measure countries' emissions. Those are the basics. And then there is this issue of what do you do in terms of transfers. So either a green fund or the distribution of free permits, okay? And this is the most difficult issue. But if we discuss it at the same time as we're discussing all those other dimensions, we're never going to succeed. I'm not saying we're going to succeed, but I think we should have a timetable for negotiations, just like for entering the Eurozone or, well, whoever. But you know, you should have some kind of timetable for the negotiation, and focus the negotiation on the distribution issue, not on the efficiency issue. The efficiency issue everyone should agree with, and we should get there. Now, this is not my preferred solution, but given that we are 6 months away from the COP21, I think this will already be a very big success. Thank you very much for your attention. Christian, do you want to join me?
So, Jean, you made a convincing case for cap and trade instead of a carbon tax, but I'm not convinced. Maybe it's because I'm too old and inflexible. I don't know. But you know, it seems to me that the main issue is an agreement, first of all. And later there's the question of monitoring and sanctions and all of that, but getting an agreement. And it has always seemed to me that it's easier to agree on one number, which would be a harmonized carbon tax, than it is to agree on a path for CO2 emissions and total CO2 emissions, and by how much does every country have to reduce emissions? Are you going to ask India and Brazil and Europe and the US to all reduce their emissions by the same amount? How do you allocate, you know, the permits? So it always has seemed to me that it would, and the main advantage of a tax is that each country collects the money. and countries like to collect taxes. So this is a good way it's an excuse for a country to collect additional revenue. So it always seemed to me that getting an agreement over a tax would be easier than cap and trade.
Okay, Bob, there are several points in your intervention. The first is countries are happy to collect a tax, of course, but they don't do it now. They could do it now. They could get lots of revenue from doing that. They don't do it. I mean, this is called free riding, so I don't think that's an argument that they just don't want to do it because it's a cost for the country overall in net. I mean, it's money from citizens flowing to citizens anyway. The question is the benefits go to foreigners and to future generations. So the idea that countries collect the tax, given that it's already doable now, doesn't work. The dimensionality argument, I think, so let me say, the point here, the argument is that if you agree on a carbon price or carbon tax, it's a one-dimensional thing. And we know, and I agree with you, that a one-dimensional negotiation is much easier than an n-dimensional negotiation. But I think it's a misleading argument, and let me tell you why. If you think about, first, I mean, with carbon, and you mentioned it yourself, you can agree on the amount of emissions. Actually, I will not do that. I will let the scientists do it, the IPCC or something. We want 2 Celsius. We all agree we want at most 2 Celsius. Here is how much carbon can be emitted. That's one number, okay? And the carbon tax, you have the same, you might say there is a profile of emissions over time, but the same thing, the carbon tax, you have to decide on the profile of the carbon tax over time, which should not be constant according to economic theory. So it's exactly the same thing. So you have, let me just say, there is one dimension, either you choose a carbon tax or you choose total emission worldwide. That's the same. Then you have the distribution issue. And the distribution issue is always n-dimensional, regardless of what solution you take. So either you can take a carbon cap and trade, and you're right, so with cap and trade, the difficult issue is, do you want to give, just like SO2, do you want to give the permits to the Midwest or to the East Coast, right? Do you want to give the permits to India or to the US? It's complicated. Green fund, it's also n-dimensional. It's exactly the same thing. Because the people who want a carbon pricing, they also want a green fund. And the green fund negotiation is an n-dimensional negotiation because you have to say, what is the net contribution, positive or negative, for each country? It's exactly the same issue. So dimensional issue is not an argument against or for the cap and trade mechanism. It's exactly the same thing in both cases, okay? And let me just say on what we propose is basically a global pass, a global emissions target. But of course, each country, just like in a cap and trade mechanism, we are not going to tell India, here is your number. We can say, you can do better, and then you'll get money. You can do worse, and then you'll pay for it. And there will be there is a standard flexibility which goes with cap and trade. So that's the proposal. But again, the dimensionality argument is not one argument because you face exactly the same issue with both systems. You have efficiency, which is one-dimensional, and you have distribution, which is n-dimensional. And the complex thing is an n-dimensional. And let me say, we economists should not, we have our own view with Christian, other people have their own views, but we should not forget, these are very important debates, but they're almost second order compared to what's going on right now. What's going on right now is that we are not going to do anything. So if we get an economic instrument, I don't like price carbon tax, but if that's chosen, I will be very happy. I'll be incredibly happy if that's what's going to happen.
Jean.
Yes, Jeff.
You were very pessimistic, and I can quite understand why. And I guess I share your pessimism with respect to the outcome in Paris. At the same time, there are positive things happening in this era, and I think it's important to try to understand what they are and what's driving them, given the general pessimistic scenario that you described. The positive things are that the price of solar power, the cost of solar power, has fallen an incredible amount in the last 10 years. I teach a course on the economics of renewable energy. I've been teaching it for 8 years now. When I first taught this course, the cost of solar power was $8 a watt. Today it's 60 cents a watt. That's an incredible drop in the cost of solar power. And there's been similar drops in the price of wind power as well. So what's driven that? I mean, what's driven that is that a small number of countries have actually implemented policies which have been enough to make an international difference. So it's been driven, the solar power has been driven by the German feed-in tariff. You know, from an economic perspective, Germany's been offering an absurdly high feed-in tariff for renewable energy, but it's been enough to actually move the needle at a global level. Various US states have these renewable portfolio standards with renewable energy certificates which are tradable, and again, prices on those are big enough to make a significant difference to the economics of this. And the solar and Chinese policy as well, obviously. And you've got to the point now where if you look at the costs of power from various sources, in some parts of the United States, and I only know the numbers for the United States, the cheapest form of energy is now renewable energy. So you can generate wind power in the US for about 3 cents a kilowatt hour. You can generate solar power for about 6 cents a kilowatt hour. Gas costs you about 5 cents a kilowatt hour. Coal costs you 8 or 9 cents a kilowatt hour. So it's got to the point where, you know, in the right parts of the US, and this is not true of the whole of the US, because you know, renewable energy costs are very site-specific. But in the right parts, you know, renewable energy is now the cheapest form of energy. And it seems to me that the right way to proceed in negotiations is to try to push this point further. I mean, to emphasize measures which will reduce the cost of renewable energy and emphasize the deployment of renewable energy. And perhaps do that, you know, at the moment we've been focusing exclusively on carbon emission targets and not been focusing so much on the development of these new technologies. And I think the development and deployment of these technologies is an area where there's a lot of scope for making progress.
Well, you're completely right on the decrease in the cost of solar energy. By the way, thanks for emphasizing Europe is the one who's spending the money, because I think we have made more effort, even so we haven't made enough. So the question is, it's an empirical question, the learning curve. In some other areas, the learning curve has been way exaggerated. For solar energy, it hasn't been exaggerated at all. So, and we don't know in advance, you know, because by definition it's unknown, we don't know in advance. Now, I will still make the point is that, you know, Germany, as you said, actually, spent, you know, 1,000 euros per ton of CO2 to develop nuclear power. Germany, I'm sorry if there are Germans in the audience, you know, it's not really a sunny country. And, you know, I would have preferred to get those solar power in Saudi Arabia, right? But it's, yeah, there's a point of hope, especially for Africa, which I think anyway is not such a big problem because we can compensate Africa. It's not a big thing. It's growing now, which is a very good news, and that's going to help quite a lot in Africa, I think. But there's the issue, is usually issue about, and it's some big issue about whether you want to deploy generations which are not ready yet, as opposed to doing research. The carbon price is very good because at the time, and it's a third best kind of issue. At the time, and we are still now with no predictable carbon price, so it's very hard to do R&D for the private sector. So you need the public sector to step in. Now, why does Germany spend so much time on solar power as opposed to Spain or whatever? It's a good question, honestly. But you know, we are in a third best world. It's very hard to know. We need some public intervention, you know, because the carbon price is not right. And that's all I can say. And there are some spillovers, I'm sure, in learning too. Now, we still need to do a cost-benefit analysis, and I don't have to convince you on that.
My point is on the cap and trade. I mean, I've been involved in CDM since around 2007, and it really doesn't work, as you were saying. Where I was, another point is, like, if you do bring in a cap and trade scheme, you get the utilities turning up to the government. So, well, if you basically impose these cap and trade schemes or don't give us free certificates, the lights are going to go out. And a lot of governments, which we're talking about, India, even China as well to an extent, don't like the lights going out because it doesn't look good politically. Where do you actually come around to addressing those needs and the political pressure of lights going out?
I don't know. I mean, in France, EDF and Engie are in favor of carbon tax. I remind you that actually a number of oil companies now, 6 oil companies, have actually argued in favor of a carbon pricing, actually, let's say carbon tax, about carbon pricing. And I think it's very important to subject utilities to the carbon pricing. I mean, the big danger, one of the big dangers, of course, is coal. And there is way too much coal. I mean, some of the coal could be eliminated in favor of gas or something else.
The largest importer of coal by 2017, I believe, by the IEA is saying it's going to be India.
Yeah.
And they say that we've got 300 years of coal on the ground.
Yes.
They're not going to change. They want to grow. They're growing at a faster rate now than China, and they like it. And I can't see where the benefit for them is going to come. They tried to introduce 5-year plans for the coal, and so the governance wasn't put in place, and of course it failed. In the UK, they're shutting down a lot of the coal plants there. Yes, they want to bring in nuclear, but there's a lot of hoo-ha on that side of things as well. So it's not just developing countries, it's also developed countries don't like this idea of the cap and trade because they see it as an added expense on the consumer.
It's very difficult then, because we had a hope, some hope with Jeff saying, solar is becoming cheaper, but now you're telling us there is all that coal. And there's no way, I mean, it's going to be a disaster if we use that coal, and we all know it. So that means that to get India on board, you have to basically bribe India. I mean, let's be clear on that. And you just have to give enough money in some way to India so that it accepts the deal. Otherwise, we are going to use all that coal with all the consequences we know, and there's no other way around. You need to do that. I mean, I understand. India is going to say, like every country, I'm not getting on board unless I get bribed. It's not only India; it's every country which does that. We have to be. The difficulty is basically there's a large gains from trade, but the claimed expectations are inconsistent at this stage. And we have to get those expectations consistent. It's just like a war. I mean, it's a good analogy. The war, you have two countries, each think it's going to win and has a right to go to war. And it's going to be a disaster for both, but each wants the other to concede. At some point, the expectation has to be brought in line, period. And the politicians have a big responsibility there.
I have a question on the credibility of the cap, because what you have said is that over the past, countries have not been so much credible on their commitments, and we have just to look at the Tokyo, for example, the Tokyo Agreement. Now, what if the majority of the countries which will accept the cap will not respect the cap thereafter, and therefore the solution of the trade does not function? Globally, the world is in a position of net indebtedness in terms of cap and energy and CO2. And therefore, how to manage that? Because here is the point. For example, in case of a crisis, many countries may decide at the end of the game not to respect the cap.
Well, let me just say Kyoto was a disaster. It was so poorly structured that it was bound not to work anyway. So that's not the paradigm we want. But you're right, Philippe, to say that actually it might be the case that actually people don't take threat seriously. And they actually all, if it's one country, that's one thing. But if there are many countries, it's just like Europe, right? If we all go into budget deficit and sovereign debt, what do you do? Because there is no one to discipline the other then. But at some point, we have to accept the fact. It's a difficult issue. I mean, it's not, you don't invade other countries, fortunately, to punish countries which are not doing their job. I think, by the way, talking about the IMF, I will include surveillance. Because it's sovereign debt, our scheme with Christian is to say, you don't have enough permits, we add to your sovereign debt. Fine. But then, at some point, if they do that 5 years in a row, the sovereign debt might go up. And you need to have some surveillance, because if the debt goes too large, then you repudiate the debt, right, at some point. So we need surveillance by the IMF as well, or something like that, to make sure that total debt is not too large. But honestly, it's very, very difficult at some point. You know, we need. But what I'm saying is that you just cannot have laissez-faire. At least the small instruments which are very imperfect, we have to use them. Okay. Thank you.
May I ask the first panelists to join me? I'm André Lévillan. Valérie, Sonia, Antoine, please join us.
We sit here? Should we go and sit here?
Sorry? Yes, please. A brief introduction to the panel on climatology. The subtitle of this panel is "What do we know so far on climate, future and climate risks at various timescales?" My own interests are in economics and finance, and I believe that there are many common points between economics and climatology. We both try to forecast the future using models and theories which are based usually on backtesting on history. And we both know that it's very difficult, so we share one common element, which is a lot of modesty, I think, when it comes to forecasting. In the case of climatology, as in economics, timescale is very important, and in the case of the climate, on the short term, we use the word weather rather than climate. And as you know, weather forecasting has made tremendous progress over the last few years, let's say up to 1 or 2 weeks. When we go to 1 year, we have reasonable statistics which can be used, especially for insurance, and many human events are dependent on short to medium term forecasting, let's say up to 1 year. It's true for tourism, for agriculture, and for a number of important public events. When it go to the long term, as in economics, the difficulty is that there are a very large number of parameters which come into play, and especially about human behavior and society and things which are very difficult to forecast. The good news is that we now have huge amounts of data which are available, that we can use history as well, and especially in the case of climate, very old history, and that we have the means and the tools to handle very large volumes of data. So maybe there is some hope there, but in any case, it's very important. So the first panelist, which I will introduce, is Valérie Masson-Delmotte. She's a physicist and a climatologist. She has worked on climatology, is the way to say it. She is a member, she has worked for the IPCC, and she was, if I have noted well, she was the leading physical monitor of the working group number 1 in the 5th assessment report of the IPCC. So Valérie, you have the floor.
Thank you. So I try to find a way to make this thing work. So I would like to focus on recent observed and projected climate change. And I will rely mostly on the 5th assessment report, but with some updates. And the first update that I would like to show now is the evolution of one key indicator of climate change, which is the mean temperature at the Earth's surface, including, therefore, surface ocean and surface air temperature. In the lower panel, the map, you see the trend from 1901 to 2012, the 8.85 degree warming, 0.85 degree warming, which is more intense above the continents and particularly strong around the Arctic due to amplifying processes. If you look at the time series of global temperature change, you can see a recent update that was published in Science last week from a team of the US National Ocean and Atmosphere Administration that shows that during the last 15 years, from year 2000 to 2014, the rate of temperature change with corrections has been the same, about 0.1 degree per decade, as during the previous 50 years. This curve also illustrates the importance of year-to-year, decade-to-decade variability. What drives global mean temperature change at this time scale? It's the energy balance of the Earth. Anything that alters the incoming solar radiation will have an effect. Small changes in solar activity, injections of particles by volcanic eruptions, reflection of sunlight by pollution particles, and increased trapping of infrared radiation by increased greenhouse gas concentrations in the atmosphere. Moreover, this warming is modulated by the variability that is intrinsic to the climate system and to the exchanges of energy between the ocean and the atmosphere. When you have an El Niño year, such as in 1998, or the one that is starting this year in 2015, you have record high temperature. What we see is an accumulation of heat in the climate system since the 1950s. Warming air above the continents and an increase in the moisture content of the atmosphere. Air that is warmer by about 1 degree can contain up to 7% more moisture. We see a reduced snow cover, a reduced volume of glaciers, a reduced extent of sea ice in the Arctic, a warming of the ocean surface, but also an accumulation of heat in the depths of the ocean. And because of the expansion of the ocean and the melt of the continental glaciers, an increasing sea level. All this is a manifestation of the accumulation of energy in the climate system. And this energy is stored, this extra energy, by only 1% in the atmospheric warming, 3% in the warming of the soils, 3% in the melt of ice and snow, and 93% of the extra energy is stored in the ocean. So any small modulation of ocean-atmosphere exchanges will alter the rate of global warming. This additional energy stored in the ocean also poses the risk of irreversible change, because this additional energy will be released later, during decades to centuries, to the atmosphere and maintain warmer conditions on the long term. I mentioned sea level rise. The mean rate of sea level rise has been about 20 centimeters during the 20th century. Since the 1990s, we observe a higher rate of increase by about 3 millimeters per year. Three terms contribute to this sea level rise: warming of oceans and their expansion, and there is spatial variability in this term, the melt of worldwide glaciers, and since about the 1990s, melt and increased flow of both the Antarctic, in green here, and the Greenland ice sheet, in blue here. Today, the remainder of the world's glaciers represent about 40 centimeters of equivalent sea level. But much larger amounts of ice are stored in Greenland and Antarctica, and I will stress the uncertainty associated to future sea level rise because of uncertainties in the responses of the polar ice sheets. We observe the perturbation due to human activities in the global mean atmospheric concentration of CO2, which has been observed since the late 1950s in blue. But the record can be expanded thanks to the composition of the air that is stored in Antarctic snow and ice. And you can see with the green dots an example of such record here during the last 2,000 years, but we also have measurements back to 800,000 years. So when you look at CO2, you can see that the concentration today is about 400 parts per million in the atmosphere, about 30% higher than at any time in the last 800,000 years. The last time, at the geological scale, that CO2 concentration was as high as today is a period called the Pliocene, about 3.3 million years ago. Temperature was about 2 to 4 degrees higher than during the 19th century. Sea level was 10 to 20 meters higher, illustrating the long-term response over thousands of years to just the same concentration in CO2 as today. We can also see here the doubling concentration of methane when compared to the background pre-industrial levels, and also the increase in other greenhouse gases. This illustrates the importance of the anthropogenic perturbation that is detected since the late 18th century, with an acceleration in the 1950s with the use of oil, and an acceleration since the beginning of the 21st century with the increased consumption of coal. What is the fate of these emissions of CO2? And I will come back to your point, Jean, about the importance of monitoring emissions. In the upper part of the graph, you see our emissions due to deforestation or reforestation in yellow, and due to the use of fossil fuels and cement. This is what we inject in the atmosphere. However, there are natural sinks in the Earth system which absorb about half of our annual CO2 emissions. You can see the increased carbon sink in dark blue, which absorbs about 1/4 to 1/3 of our emissions. And you can see the variable absorption of CO2 in soils and vegetation. And of course, this absorption over the continents is limited by water availability, and therefore the land carbon sinks depend on climate. So each year, about half of our emissions stay in the atmosphere, add to the earlier accumulated CO2 emissions, and therefore have a very long lifetime in the atmosphere that extends over hundreds to thousands of years. Just one point also, the capability of natural sinks to absorb CO2 emissions depends on the emissions. So if we reduce our emissions, the ability of these sinks will also decrease, which adds to the challenge. If we look at all the terms that act on the Earth's climate, you can see here their expression in the way they act on the heat budget of the Earth. It's expressed in watts per square meters of radiation that is trapped in the Earth system. On the upper part, you see the drivers that act to warm the climate system. On the lower part, those that act to cool the climate system. In the anthropogenic factors are dominated by the warming effect of CO2, which is the most important gas acting to warm the climate, and methane. And the other gases have a trace effect. On the cooling side, you can see the effect of pollutants, aerosols, their direct effect and their indirect effect through the formation of certain types of clouds. And you can see that what dominates since the 1950s is the warming effect of greenhouse gases, partly compensated by the cooling effects of some of the aerosols. In the public debate, you also hear that solar activity plays a key role on the climate variability, and you can see here the 11-year cycles of solar activity, which act weekly on the net radiative budget of the Earth on a scale of about 10 years. You can also see the very large role of volcanic eruptions that act as cooling factors for a couple of years. The last major eruption was the Pinatubo in 1991 that had an influence on climate on the following years. Understanding the behavior of the climate system requires to understand its response to each of these drivers, and this is critical to understand the role of human influence on the climate system, the role of solar activity, the role of volcanic activity, and then the part that is due to the chaotic nature of the ocean-atmosphere interaction and that we call internal climate variability. In order to understand the response of the climate system to these different perturbations, we rely on climate models. And I would like to stress that they are not like economical models. Why? Because they are based on physical principles, conservation of heat, conservation of matter, And so the underlying principle is to calculate the transport of heat, the transport of moisture, the exchange of carbon between the atmosphere, the ocean, the land surface, the cryosphere, so the snow and ice part of the climate system. However, despite the fact that they are based on physical principles, they are associated with intrinsic uncertainties. There's a limitation in computing power, and the equations are resolved on grids that have a limited size, typically 100 by 100 horizontal scale for the atmosphere. And the processes that act on smaller scales, turbulence, cloud formation, they are simplified, they are represented in a semi-empiric way. These aspects are tuned to the observations available for present day. So with the progress of observations, climate models evolve continuously through time, and a number of key features that are obtained are robust with respect to the evolution of these climate models. So the increment in differences in projected patterns are in fact rather small, because the first order signals with respect to the large-scale energy response are quite robust since the 1970s. So climate models are used to understand the mechanisms at play today. They are used to understand the mechanisms at play in the variability and the change that I have just shown. They are tested against past climates. Are they able to simulate warm climates of the geological past with higher concentrations of CO2? The answer is, on the first order, yes. Are they able to simulate extreme cold climates, such as the last glacial climate maximum, the last ice age climate, associated with the presence of large ice sheets and a lower amount of greenhouse gases in the atmosphere? And the answer is yes. So key aspects of these climate models are the result of multiple feedbacks. When you alter the climate system, you change the temperature, you change the water vapor that the atmosphere can contain, you change the clouds, their effect on the radiation exchange, you alter the sea ice, the snow cover, the heat content in the ocean circulation. And the overall result of all these small-scale processes, which we call the sensitivity of the climate to a given radiative perturbation, is correctly represented, as we can test that against past large-scale climate variations. So an example of simulations performed with these climate models is a retrospective simulation since the mid-19th century until today. And we can make ensemble simulations with the 40 different climate models that are developed in the world, only with natural forcings, solar activity, volcanic activity, with different initial states, and start again the same simulations, including the influence of human activity, aerosols, land use change, and greenhouse gas emissions. What you can see here is that with respect to the observed decadal changes in temperature in black, when we account for the human influence, we explain correctly the amplitude of the warming, the timing of accelerated warming since the 1950s, roughly, the fact that the warming has been larger at the land surface than at the surface of the ocean. We also explain the amplification of the warming around the Arctic, and the fact that the ocean is accumulating heat gradually into its depths. And this is the basis for the conclusion for a dominant influence of human activities on observed warming since the 1950s. And recently, this conclusion has been expanded to a dominant human influence in water cycle changes, reduced snow and ice extent around the Arctic, sea level rise, and changes in extreme weather events, and Sonia will get back to this point. I would like to stress that the strongest conclusions are for heat waves and heavy precipitation events. For the future, scenarios are established, and they are formulated in pathways of radiative perturbations. That means how the human influence only will alter the radiative exchange between Earth and space. So these scenarios, which are called RCPs, are expressed in watts per square meters of perturbation. So today the anthropogenic perturbation is at about 2.3 watts per square meter. Since the last decades, we are on the red line, so the high-end scenario. And if we continue to exploit fossil fuels and multiply by about 3 the emissions of CO2 associated with the use of fossil fuels, it is expected that this radiative perturbation could increase from about 2.3 watts per square meters today to about 8.5 watts per square meters at the end of the century, and that's the name of the high-end scenario, RCP 8.5. There are intermediate scenarios of stabilization, and one scenario that includes strong climate policies of emission controls. That scenario assumes that the anthropogenic perturbation will reach a maximum of about 2.6 watts per square meters in the 2040s and then slowly decrease. Given the time constant of the carbon cycle, these scenarios, they imply very different trajectories for emissions, and that's counterintuitive in a way. The high-end scenarios assumes that the annual emissions of CO2 will be about multiplied by 3, and then they don't need to increase. In a much warmer world, the ability of carbon sinks to store CO2 will be decreased, and even with stable high emissions, the concentrations will continue to go up in the atmosphere and the radiative perturbation to go up. In the low-end scenario, the path to reach it is a peak in world CO2 emissions in the next 10-20 years, instead of a growth of about 2 to 3% per year, a sharp decrease, and zero emissions worldwide at the end of this century. So these different paths assume completely different policies and different development targets, different energy and agriculture and land use transitions. What does it imply for projected climate change? In the low-end scenario, the result of all climate models is a warming that would go up at about the same rate as during the 20th century until about 2050, and then a stable global mean temperature with only a slight decrease. All the other scenarios lead to an acceleration of warming at the Earth's surface, going up centuries after centuries. And the high-end scenario leads to a strong acceleration of warming with about 4 degrees more at the end of this century and 4 degrees more 2 centuries later. Just to give you an idea, this would lead us completely outside of the range of climate variability during the last million years, during the last glacial, interglacial periods, where in the warmest phases, temperatures were not more than 2 degrees above the pre-industrial level. The fastest past change that we know is the transition from the last ice age to today, and it occurred at a pace at most of about 1 degree per 1,000 years. So the high-end scenarios is worrying both in terms of amplitude, but also in terms of rate of change, with respect to the adaptation capability of ecosystems and adaptation capabilities of our societies. So I would like to stress the multi-centennial response and the committed aspect of climate change, the unavoidable part that is ahead of us in the next decades, whatever is being done in terms of climate policy, and the fact that the multi-decadal amplitude strongly depends on greenhouse gas emissions. Warming is expected to be amplified above the continents, as observed today, and around the Arctic. In the high-end scenario, it is expected to have a vanishing Arctic sea ice during summer in the second part of this century. For precipitation, what is projected is a much more contrasting pattern, and I think Sonia will come back to the drivers and uncertainties associated with the changes in precipitation. There are large sources of uncertainties, and the more we perturbate the climate system, in fact, the more we add uncertainty. In the insurance sector, you know very well how to use the past information to know about the future risks. But the more climate is changing, the more new risks will occur. So this increases, in fact, the uncertainty. At the global scale, there is uncertainty due to internal variability, El Niño, La Niña, decadal variations. There is uncertainty that we can quantify through the spread of the different climate models. And there's uncertainty associated to the scenario. On the short term, internal variability can be dominant. In the mid-term, 20, 30 years, model spread has a large role. At the global scale, the scenario is the key source of uncertainty on the long term. And this is different for different aspects of climate change. For instance, if you look for Europe and changes in, let's say, winter temperature, which is important for the use of energy, for instance, you can see on the short term, internal variability is dominant. You can see that even over 40 years, the model spread is large with respect to projected changes in European winter temperature. And only at the end of the century is the scenario dominant. I would like to stress, I'm a paleoclimatologist, that we can also provide useful information on the short term. We now have a 1,000-year estimate of the North Atlantic Oscillation, which is a key driver of European winter temperature or precipitation variability. We can characterize its natural variability over 1,000 years, and we can also show that it is strongly predictable in response to volcanic eruptions, with a systematic response 2 years following major volcanic eruptions. And this can also be used to bridge the gap between weather forecasts and long-term trends, if there is a strong forcing, such as from volcanic eruptions. And just a last word about key uncertainties. Of course, sea level is an important point. In the low-end scenarios, we expect sea level to rise 2 times faster this century than in the 20th century, about 40 centimeters. In the high-end scenario, we cannot rule out 1 meter sea level rise risk, and there are large uncertainties on the potential contribution from the Greenland and Antarctic ice sheets. There's a warming threshold that leads to deglaciation of Greenland between 1 and 4 degree global warming. And recent studies suggest that unstable sectors of Antarctica could contribute up to 5 meters in 200 years of sea level. And there are lots of ongoing works to try to reduce these uncertainties or quantify them in the best ways. So thinking of climate policies, the policy target is 2 degree warming. But thinking of impact, it's very difficult to define a system, a threshold that avoids dangerous impacts of climate change. We already see impacts of weather events. We already see an increasing scale of impacts, and of course, large and fast climate change increases the likelihood to surpass adaptation limits. So the last slide is what we can provide with respect to climate policy. And global warming is projected to be related to cumulative CO2 emissions. So if we want to have a good chance to contain warming below 2 degrees, we shouldn't emit more than 3,200 gigatons of CO2. We have already emitted 2,000, half of that in the last 40 years. So what is the remainder is about 1,200 gigatons of CO2. If nothing is changing, this will be reached in 20 or 30 years from now at the current rate of increase. Thank you for your attention.
I suggest we keep the questions for the end, and I'll give the floor right away to Sonia to talk about extremes.
Yeah, thank you very much. So I would like also to thank the organizers for the opportunity to speak today. I will also try to figure out how this works. Okay. So as mentioned, I will talk about projecting and attributing changes in extremes. And I want to focus on land regions because that's where we are living. And I will discuss mostly about heat waves, droughts, and heavy precipitation events. I will base most of my presentation on two recent IPCC reports. There was a fifth assessment report, and the report on the right is the contribution of Working Group 1, so the part on the physical basis. And there was also the year before a special report of IPCC on extreme events, which I contributed to as coordinating lead author, and I will base also some of my presentation on this. So I thought maybe it would be easiest for me to just start with the main messages, and I have three main messages. So the first one is that a global mean temperature is not necessarily a good metric when considering impact. So generally, in the public debate, often we just hear this 2-degree target. I have the impression in terms of communications, it doesn't sound very bad. You say, oh, 2 degrees, that's not a lot. And as I will describe today, this means actually some very large temperature increase on regional scale. The other point I want to say is that increased greenhouse gas forcing doesn't necessarily mean that you have increase in extremes, all types of extremes. Some are strongly affected by climate change, like heat waves or heavy precipitation events. Regionally, possibly droughts, but links for other extremes are not established, so we still have some uncertainties on some other extremes. Finally, I wanted to discuss briefly some new research linking the aspects of regional climate mitigation and adaptation, and showing that we need to consider jointly the effects of measures which affect both the carbon cycle as well as physical aspects of the climate system. So I'm also starting with a figure similar to the one showed by Valérie, showing the projected increase in global average surface temperature. And I'm very happy for a great presentation because this gives most of the background here that you need to understand these figures. So as mentioned, you have different scenarios. There are CP scenarios. And the blue one is the one with least emission. Actually, it requires even negative emission. That means that CO2 would be taken out of the atmosphere. At the moment, we don't have the technology for that. If we have the business as usual, this is basically the RCP 8.5 scenario, so the red one. As you see, by the end of the 21st century, we have an increase of 4 degrees for this scenario. So, but what do these projections of global mean temperature changes imply for human population? We need to look at inhabited regions and extremes. Valérie mentioned that there is this amplification factor over land. So as you see from this map, you have a greater warming of the land compared to the ocean. You see that if you look on average over land, you have about, so as mentioned, you have this 4-degree warming for global mean temperature. But if you look over land, actually, looking at the shading, you have an increase of about 4 to 7 degrees. So you have an amplification of factor of 1 to 1.75. But now if you're interested in changes in extremes, so let's take, for instance, hot extremes, so the hottest temperatures that you have every year, the one temperature that occurs only every 20 years, that's the figure I'm showing here at the bottom. Well, for this, the increase are massive. So for these hottest temperatures, the increase is up to 7 to 9 degrees, so it's double the warming of the mean global temperature. So it means that, for instance, when you speak of 2-degree targets, we mean an increase of the hottest temperature of 4 degrees. If you go business as usual, you have an increase of up to 9 degrees for this hottest temperature. So, of course, a very strong impact. I wanted to discuss briefly recent changes. This is a study that we did with some collaborators in Australia. And Valérie has also mentioned that there was this discussion of the recent pause in the temperature increase. This was actually one topic of the IPCC report. And what I wanted to mention here is actually if you are looking at hot extremes, you had a continued increase here during this period. And in addition to this, the mean global temperature actually didn't show this pause. Now, the most recent evaluation, as also discussed by Valérie, published last week in Science, shows that, so that's basically the squares here, shows that actually the rate of warming was the same for different time periods. So I mentioned the changes in extreme hot temperatures, and we see that these are increasing, like mean temperatures, both in observation and in projections. How about other extremes? First, I wanted to discuss also water cycle changes. So this is a figure looking at projected changes in precipitation. An important point here is that the changes are not all going in the same direction. So the blue is showing basically regions which have an increase in precipitation. Yellow shading shows regions where you have a drying. So basically you have regions which are projected to have more precipitation, some are projected to have less precipitation. In terms of impact on extremes, it's a bit more complex. So if you're interested, for instance, in changing in heavy precipitation, maybe it's a bit counterintuitive, but even regions where you have a mean drying in precipitation would have an increase in heavy precipitation. So you see this figure here is showing that actually in most of the globe you have a projected increase in the heavy precipitation source. And that the main reason for this is that you have more moisture in the atmosphere. So basically, when you have a precipitation event, even if those precipitation events occur less frequently, they are more intense. For droughts, it's a bit more complex. There are some uncertainties. I'll come back to this figure. The dots are showing why you have consistent changes in precipitation. And you see the yellow shading, you have some consistent drying in the Mediterranean and part of Europe, but for many other regions, actually the changes are not very consistent. So for instance, there's a lot of debate of whether there might be increased drought in the Amazon region. As you see already for precipitation, the signal is not very clear. So this is an analysis looking at changes in runoff that was also published in the latest IPCC report. And it's basically looking at the amount of moisture available from discharge or from runoff and rivers. And yellow to red shading is showing drying, and green to blue shading is showing wetting. So you see that there are a few regions where you have clearly drying. So again, the Mediterranean and Central Europe. In part also North America, maybe you know that at the moment there is a major drought in California. Actually, in parts of North America, we do see projected increase in drying. But a lot of regions are showing some white shading. These are regions where the sign is uncertain. So I want also to bring up this point. Nonetheless, the important point is those regions where we see a consistent increase in drying are actually important agricultural areas. So you see here the yield production. And you see that we have most production, agricultural production here in Europe and North America, and these are regions which are projected to get drier. I want to just a side remark maybe in terms of communication. Sometimes you hear the statement that dry regions are getting drier, wet regions are getting wetter. New evidence is suggesting this is not really a correct summary. So this is actually based on observation. And at the top, I'm showing where dry regions are indeed becoming drier and wet regions getting wetter. There are actually less regions showing this in historical changes than those which are affirming this. The main point, and maybe this is a bit counterintuitive again, is that some tropical regions, for instance, here in Africa, have become drier. And even in the future, the projected changes are not very consistent. So maybe that's also something to keep in mind. Because maybe in some regions you have the impression, okay, we have a humid climate, we should not be worried. Actually, some humid climate could also become drier, and this is a bit counterintuitive. So I wanted also to come to the question of uncertainties. Valerie has shown this as well. So we have different sources of uncertainties for projections. One is internal climate variability. If you go to the end of the 21st century, the main source of uncertainty are scenario choice, so basically what are the emissions. The other one is model uncertainty. And the fact that we have model uncertainty doesn't mean necessarily that it makes the decision easier, and you need to take this into account. I'm sure there's also uncertainty in terms of economic modeling. I just want to show the impact of uncertainties in dryness. So this is a study looking at the sustainability of present-day water consumption. So a study looking at what are the water trades, virtual water trades between countries, and then just keeping the same virtual water trades, but looking at the projected changes in moisture availability. There is a large uncertainty in projection of moisture availability at the surface, as I've shown. Now, if you take the wettest scenario, so 10% wettest scenario, that's the projection for this sustainability of water trades. And one means that actually you have no problem to sustain the water trade. So actually, if you take the wettest scenario, it doesn't look like we have much of an issue. On the other hand, if you take the 10% driest scenario, you see that in many regions of the world, actually you have large problems. And actually, some of the impacts may be counterintuitive. So even a region like Russia, which rather wet regions, also have a diminution of its virtual water trade because it's importing goods from regions which have drier climates. Now I wanted to just provide a summary of attribution or detected changes in extremes and projection of changes in extremes, just discussing the fact that the robustness of projection is a bit varying depending on the extremes. So as mentioned, for hot days, so the increase of hot day frequency or the magnitude, the detected changes is very likely. So that's a summary of both the SREX and AR5 report and the projection here. So it's very likely there's been an increase, and virtually certain there will be a future increase in the future. Regarding, so we should also discuss that some extremes will decrease. So of course, cold days will become less frequent. There will be also less cold, so it will get warmer. And this is very likely available in the observed record, which shows certain to change the future. Regarding heavy precipitation, it's also one change where we have quite a strong amount of certainty. So we see likely more regions which have an increase in heavy precipitation. In the projection, we see likely increase in many regions, and very likely there are 5 mid-latitudes and tropics. Regarding droughts, as mentioned, we have less certainty. So regarding the observations, there is medium confidence that there are some regional trends. So we don't see a global trend, but we see some regions with some trend. But some go in the direction of an increase or a decrease. Regarding projections, we have medium confidence in the increase that was from the SREX. The R5 was a bit more certain, so it's stating likely increase in some currently dry regions. But it should be stated that it's not really dry regions getting drier, but it's rather transitional regions, so this should be changed. I should just state that some other extremes, actually, we have much higher uncertainty. So for instance, for storms, there is low confidence of any impact so far on greenhouse gases on storms, and we have also low confidence in detailed regional projections. For floods, there is low confidence because there is a very strong impact of human water use, and we have also low confidence in regional projections. But there is medium confidence related to an increase because you have this increase in heavy precipitation events. Regarding tropical cyclones, there is low confidence in historical changes, but it's more likely than not an increase in intensity in some basins for the future. So it's just to say that, of course, we also need to take into account that the impacts on extremes are very variable depending on the considered extremes. So not all extremes are projected to increase, and this need to be taken into account. Now I want to come to the last point, which is connections between regional mitigation and adaptation. Is a bit more newer research. Generally, you have this picture that you have global emissions of CO2, which lead to a global mean change of temperature. And then this is kind of connected to regional changes in extreme. So the general view is that we need to reduce CO2 emissions. So we want to achieve mitigation through a reduction of CO2 emissions. So each region tries to reduce CO2 emissions. And so we have regional measures which are aiming to achieve this mitigation through the CO2 reduction of CO2 emissions. But one aspect that is often not considered is that those regional measures may also at the same time impact regional changes in extremes. So some regional mitigation measures could lead to direct regional warming or cooling. This is often not considered. And so these effects on CO2, the effects of the measures on the CO2 emission, cannot be considered independently of the effects on regional climate. So I want to show a few examples. We discussed there's one measure that is often mentioned regarding the CO2 uptake, so basically reduction of CO2 in the atmosphere, is afforestation. So we know that if we plant more trees, we can take up CO2 from the air. This is a picture from a study from Bonan in Science, showing that, of course, you can have forests in different regions. You can forests in tropical regions or in boreal forests. And those forests are very different. So in tropical regions, you will have very large trees, which take, I'm not sure if you can see the arrows, but the gray arrows is basically carbon storage. So there are three main functions. So trees can take up carbon. They also evaporate water. And the other effect is that they modify albedo. So they modify the reflectivity at the surface. And actually, a tree compared to basically grassland will have a darker albedo, so actually it leads to warming because there is more radiation absorbed. So actually, it's leading to warming. This net effect in the tropics is not very large, but it's actually very large in high latitudes because there you have background snow. So if you have trees, they are going to shade the snow. If you have grass, actually they will be covered by the snow. So the net effect of forest in the high latitudes is rather warming because you have basically hiding the snow, while if you have grassland, it would be a cooling. So there was a study, and there have been other studies confirming those results since, trying to consider the balance of effects of afforestation. On the one hand, in terms of cooling through the impact on CO2, but on the other hand also through this direct effect on albedo, so actually the warming effect in high latitudes. And the color shading here is not very good, but what you see is if you are on this side of the color bar, you have a net cooling effect of afforestation. This is the case, for instance, here in Europe, and also in part of North America, and it will be also the case in the tropics. But if you go to high latitudes, where you have high snow cover, actually the net effect of afforestation is a warming. And this is not considered in climate negotiations. So of course, when we design those climate negotiations, we need to also consider this non-direct effect of specific measures, which could also affect climate regionally. Another example is, for instance, the impacts of agricultural management. Here, one example on no-till farming. So this is just a picture on the left. You see some fields, some are tilled and some still have residues at the surface. And again, you have a strong impact on albedo, so the reflectivity of the surface. If you have a tilled soil, if you see here, basically you have again a darker surface, so basically we'll have more radiation absorbed. So this leads to a net warming. If basically you have no tillage, you will still have the residues, it will reflect more radiations, will lead to a net cooling. These are actually measurements from France in Avignon, and you see the daily albedo in the case of conventional tillage and when you have no tillage. And the net effect on albedo is 0.1. So it means the albedo is the percentage of ratio of reflectivity, so you have 10% more reflection of solar light when you have no-till farming. And actually, no-till farming is also considered to conserve CO2 in the soil. So on the one hand, there is an impact on CO2, but also on the other hand, a direct effect on radiation. So we had a study on this trying to look at the impact of no-till farming, so change in surface albedo in agricultural surface for temperature. And just the effect of albedo is shown here for different quantiles of distribution. So you're looking here, this is the median, if you're thinking of the temperature that is occurring most often, and that's 99 percentile, that's the hottest temperature. These are the coldest days, so in summer. And the interesting effect was that there was a stronger cooling for the hottest days compared to the median day, both in Southern Europe and Northern Europe. And the reason for this is that when you have very hot days, you have no cloud, so basically you have much more radiation, so the effect of the surface albedo is stronger. So I just wanted to mention also this, that some measures to reduce CO2 emissions may either be counterbalanced by enhanced regional warming, so actually afforestation in high latitudes, which actually is not effective to lead to cooling, or in some cases you can have some synergies, so they could lead to decreased warming, so basically you could at the same time store more carbon and also have increased cooling regionally. These effects are not considered in climate negotiation, but they should receive more attention. So I come again to the main messages. Again, global mean temperature is just one number, but you need to look at regional scale, and just for temperatures, for instance, you can have a doubling of the impact on temperature on regional scale for extremes compared to the impact on global mean temperature. So twice larger warming of what extremes compared to global mean temperature on land. There's also an uncertainty range, so the uncertainty, as Valérie mentioned, also is getting larger and larger when you go to regional scale. Certainly some extremes are affected by greenhouse warming, so especially heat waves, it's very clear, hot days, heavy precipitation. Regionally, we see some impact on droughts, and what is important is this is affecting many regions where you have agricultural production, but in some other regions the sign is uncertain. And then for other extremes like flood storms or tropical cyclones, we still don't know, which doesn't mean that there is no effect, it's just that it's not quantified yet. Finally, regional climate mitigation and adaptation scenarios need to be considered jointly and encompass both carbon cycle and biophysical effects. And this is not considered yet, and I think this should be considered with more detail in the future. Thank you.
Antoine Flau, MD, biomathematician and a specialist in physical health.
Public health. Yeah.
Public health.
Many thanks, Mr. Chairman, and Hello, ladies and gentlemen. I'm very pleased and happy to have been invited to maybe to try to take into account what we have heard from Valerie and Sonia, and to see how it can have an impact on health. The first thing is what we have heard today is all these changes in our environment may have impact on health. The drought we have thought about, the melting ices and the change in plant life cycles, the rising sea levels, the warmer ocean, the coral damage, the stronger storms, changing rain, higher temperatures, heat waves. All these events, either extreme or not, may have an impact on health, and that's what we will try to review now. What has been said by the public health community, and this presentation has been worked together with Andy Haynes from the London School of Hygiene and Tropical Medicine and Stéphanie Schutte from Paris Descartes Center Virchow-Vierme. What has been said was that the climate change could be one of the most important threats to public health. Why? Because the impacts on health may have several components. We have seen that probably the heat waves could be something which is really clearly linked with climate change and conduce to illnesses, injuries, and deaths also. What is very well known and also very debated is the disease transmissions, particularly the vector-borne disease transmission, because of the potential for the global warming to increase the population of insects, of vectors, rodents also, and therefore for more infectious disease, so more illnesses and sometimes more death. What is also clear is the greenhouse gas emissions are often air pollutant and therefore prone to an increase in respiratory disease and therefore to illnesses and many deaths are related to respiratory disease. What is also expected, although more indirectly, is if there are some shortage in food supply, that could lead to malnutrition and therefore to an increase in health problems. The extreme weather events, which are clearly, more and more clearly associated to global warming, could lead to illnesses and injury, could lead also to displacements and sometimes to civil conflicts. Storm and flooding and probably the sea level rise could also lead to displacements and to some other kind of illnesses, particularly the waterborne disease. We have seen that there is an increase in frequency of extreme weather events. That's facts observed for decades. And we also can see that this warming, according to the various scenarios, may lead to an increase in heat waves. And we know that in France particularly, but in all over Europe, in August 2003, the heat waves were responsible for a large number of excess mortality, particularly in vulnerable segment of the population and particularly among elderly. So it is something we have to expect, to prepare, and probably to try to prevent. What is also interesting in some works which have been published regarding the ability to work according to not only the temperature, as it has been said, temperature is not only one determinant, but also humidity. And we can say that there is a kind of threshold level above which it becomes difficult to work effectively, we can say. And this is something which is a cause of concern. If the extreme scenarios are to be expected due to a lack of action that may lead to a real inability to work and to live in some part of the world, and that could lead to stop the evolution of growth and of reduction of poverty, particularly in sub-Saharan Africa, which may be really impacted by these excess warming and particularly prone to limitation in their work activity and therefore in their economic production. As I said, probably what was the most well-known, could appear as the most evident, which is not, in fact, is the impact on the climate change on mosquito-borne disease. And malaria is one of it, with a high level of burden in terms of morbidity and mortality. And in Zimbabwe, there is some locations where most of the cities are and most of the populations are located is on the mountains, which are a little cooler and less able to host mosquitoes. But due to the projections on global warming, these highlands may be threatened and may be, in fact, prone to more invasions of the mosquitoes and therefore kind of amplifications of the malaria, which were more or less under control in these recent years. So all these benefits of the control of malaria could be jeopardized by this global warming in the next years. What is not so well known and seems to be clearly linked to rainfall is the fact that when there is drought and decrease in rainfall, there is an increase in diarrhea incidences. Sometimes people think it's the reverse because of it is waterborne disease. If there are floods, there will be diarrhea. It may appear. It's true that cholera, for instance, is often linked to flooding. But when there is shortage in rainfall, when there is drought, there is probably some reduced effect on hand washing. It's not so clear the reason why, but what is sure is that there is a significant increase in diarrhea, and diarrhea is one of the most deadly diseases among children in low and middle income countries. We have seen some impact in the crop, in the production, agricultural production, which again, as we have seen by the previous two talks, is completely heterogeneous in the world. Some regions of the world may experience better crops, higher yields in 2050, and some, and particularly in the eastern part of Europe and maybe in Canada, and some other may experience a shortage and decrease in their food production. What is not clear today is if this excess of yields will compensate the decrease in yields in the other part of the world. So we have also, and all these projections did not take into account flood, storm, fire damage, and sometimes pests and drought and infectious disease. What is sure is there are some work showing the increased numbers of stunted children according to these various scenarios, and an increase in 6 to 9 million of stunted children due to this problem of climate change and effect on food crops in South Asia and in sub-Saharan Africa. The flooding is something which probably will occur more in closing to the delta of the major rivers in the world, and the Nile, probably the Ganges, and also the Mekong, but also the Mississippi will be prone to experience more flooding and more displacements and more injury and illnesses, as we said, and all these river may be prone to also these flooding experiences. And we can see more or less these events happening, and we have seen in Pakistan, in China, in Russia, either floods or drought or fires, which are kind of harbinger of what is expected to come with all these record temperature we have noted and observed in the past decades in several countries. What is also something in terms of global health, which is striking and which is really unfair, is that the countries which have polluted and emitted more in the past century is not the location where these impact on health are happening. I say happening today. It's in year 2000 that Africa and in a lesser extent South America, but also India, Asia, Southeast Asia, have experienced this malnutrition, diarrhea, malaria, flooding, excess of that due to and attributed to climate change today. We often say, yes, we will adapt. The mankind is so genius, it will adapt to. But there are some limitations to adapt to these evolutions. There are for sure physical limits. If the Cayman Islands are flooded because of the sea rise level, they will not adapt. They will have to move. We have seen also that the behaviors of our population, even when they are aware of a storm, of a hurricane, even in the very developed countries as in the USA, did not suffered a lot, did not adapt and did not move when they were required to. And some technological limits, we can implement some flood defenses, and we know that they do not work so well. So what is sure is we have to convince that all the actions and the interventions which are proposed today to reduce the gas emissions will have these co-benefits Jean Tirole spoke about, and particularly co-benefits on health. We will see that there are co-benefits in housing, there are co-benefits in new mobilities, urban mobilities, there are co-benefits in food and agricultural sector, there are co-benefits to health in also this low carbon electricity generation. And what is sure is the greater the CO2 emissions and the higher the respiratory disease are occurring. So one of the first co-benefits of reducing the pollution and the CO2 emissions is a real benefit, an immediate benefit. It will not after 50 years, it will be an immediate benefit in terms of respiratory disease, which is a high burden in various Asian cities. It is a burden everywhere, but it is particularly a cause of concerns in China, in India. And when we know that India and China are not so convinced by during the negotiation by the agreement to reduce their emissions, even if China is making a lot of change on that direction, we can think that these co-benefit on health could be something which may motivate more the politicians to agree on, because the pressure of the populations to reduce these air pollutions is very important. The global burden disease estimates for air pollution is huge, is equivalent to the global burden of disease due to tobacco. Of course, tobacco also could be, smoking tobacco could be avoided. But the air pollutions today, ambient particulates, of course, but also these solid fuels, many households, many in low and middle income countries use for cooking or for heating are a real source of indoor air pollutions, which have an important burden in terms of respiratory disease. The benefits on household energy efficiency may save lives not only in India or in sub-Saharan Africa, but also in London, in the UK, which has been estimated to avoid more than 5,000 deaths a year by just good household energy efficiency. It has been estimated also that this active travel in urban cities such as London may have huge effects against diabetes, depression, cancer, breast, bowel, and in terms of cardiovascular disease because of mobility, because of walking, biking, we would avoid not only gas emission but also cardiovascular disease and all these diseases which are more or less related to that, because we know today that physical activity has a tremendous effect on dementia and, as I said, cancer. Of course, road traffic crashes, if you use bike, you are prone to road traffic crashes, but the balance is better than the worst effect. Food and agricultural sector, it's not so well known that when you eat red meat, you, of course, need to have cows, and the total emissions in sectors of livestock production is 80% of the agricultural sector. And the agricultural sector is a huge amount of gas emissions. So eating less meat, and particularly less red meat, more vegetables is very good for your health, but it's also very good for gas emissions, for reduction in gas emissions. It has been calculated that reducing, we are not talking about everyone to be vegan, but if we reduce our consumption of red meat by 30%, and we may reduce also the mortality by a significant number of deaths. So there is real co-benefits by behavioring healthy diets, physical activity more for health and also for gas emissions. The new technologies for clean energy, it is striking to see that, in fact, all the energy we consume today is, in fact, the solar energy, which is in this very little square, in Sahara. And so if we are better in using and exploiting this solar infinite energy, we may probably have good effect on low carbon emission. What I wanted to say also is that the health sector itself is a producer, a heavy producer of greenhouse gas emission. And so there is also some thinking about green hospitals, how to make the health sector less producer of greenhouse gas emission, designing to reduce energy use. You know, the health sector has a culture of throwaway. We throw away everything because for security reasons, for safety, the device are just to be thrown after use, and all these things is very important. We don't want to reduce the need for safety, but maybe we need innovation. We need to invent things which are more prone to limit these greenhouse gas emissions, which are heavy in the sector, but also to have a hospital closer to the population, but also to have hospital vehicles, maybe electric driven and so on, to encourage public transportation, to reduce animal product consumption is something also we need to implement within the healthcare sector itself. So what I wanted to say is that what is important, and maybe what is a kind of positive message of the actions against the greenhouse gas emission, is not only to reduce the growth, to reduce the potential for income, to reduce the potential for even consumerism life, but it is also good for our health. And what I wanted to stress, maybe my last point I wanted to stress, and was the fact that if we cannot achieve the goal in Paris and the year after to control this global warming, maybe what will be very difficult to limit is the poverty. We have decreased poverty in the world tremendously and dramatically in the last decades, in the 3 last decades. All the Millennium Development Goals are maybe not achieved, but underachievement, and the reduction of poverty is absolutely fantastic. By half, it has been reduced in the past 15 years. If we continue on that direction, when we know that income is the main driver, is the main determinant of health, if we cannot succeed to maintain this pace, it may really jeopardize our health in the future. Thank you for your attention.
Well, thank you all 3 speakers. I think we have time for questions. Can we get the lights on and open the floor for questions? Micro?
Can you hear me if I...
Oh, we'll get you a mic very quickly. Au troisième rang à droite, s'il vous plaît. À droite, à ma droite.
Thank you. So the issue really is adaptation. I'm curious, you mentioned that in 2003 there were, I forgot how many, 13,000 deaths in France from 15,000 in France from the heat wave. Has anyone done a study to estimate what would happen this summer if there was the same heat wave in France? How many people would die? Has anybody? Surely there's been some adaptation.
May I answer?
Yeah, Antoine.
Yes. Thank you for this question. In fact, it was a real drama in France. Of course, it was a devastating impact on elderly, 15,000 deaths. It was the same in Europe, but maybe France was the high spot, if I can say, of this heat wave and the consequences. And of course, a lot of it was not so well known in France at the ministry level, but also at the doctoral level, that the heat may kill. So we learn that for sure. It was maybe surprising because the US had experienced the same kind of things and knew that, and so used some intervention measures to prevent the fatality due to the heat. So nowadays we could say that there is a kind of preparedness plan to foresee that. Of course, not to foresee in terms of climatology or whether the weather will be forecasted, but if there is a heat wave which is forecasted, there is some intervention and a preparedness plan to try to prevent further death. It is sure that there will be an excess mortality anyway, but it may be highly preventable. So there are some cooling and some water supply, particularly to the elderly during the vacations, which may be very low, and so they are really located and help for that.
And have you incorporated those adaptations in your projections of deaths and illness from greater temperature variability?
Maybe just one comment also on this. So on the IPCC special report on extreme events, we had a case study on the 2003 heat waves. And so another interesting result was in 2006, there was a very large heat wave in Europe. And actually, the number of deaths was much reduced compared to 2003. So already there, you could see that there was adaptation in place, which had some effects.
And the weather forecast for this last weekend in Paris was for over 30 degrees C, which didn't happen, by the way. But there were public announcements that we should take care of the people in view of this expected heat wave of the weekend, which didn't happen.
Just one word, it's the fact that the people who died from the heat wave, in fact, were exposed also to poor air quality with high ozone concentrations, and therefore in the plans to prevent further deaths, There are the warnings that were mentioned, the air conditioning in retirement houses, the warning systems at the city level for isolated old people, and also the requirement to act on air quality if this situation would happen again.
Have those adaptations, are they included in your projections of what would happen with greater variability and so on?
So it is asked if the adaptations are included in the provision we have presented. In fact, we have not presented provisions of figures due to heat waves in Europe in the next future. So what is sure is that there are some predictions of an increase in heat waves events, but the number of deaths due to that has not been presented here. And to my knowledge, there is no work on that today. But you are completely right. We have to understand that there is a kind of adaptations, fortunately, and we can learn from the past here.
Just make a quick comment on that. There's a paper by Olivier Dechaine and Michael Greenstone looking at the effect of heat waves on deaths in the US, which shows that the penetration of air conditioning has had a huge impact. If you go 50 years back, you have the same kind of impact as you've had in Paris. Today, the effect of a heat wave on mortality is almost zero. And they correlate that very tightly with the spread of air conditioning. They've managed to get air conditioning data by county in the US.
If I can just add a word, it's completely true. What was not completely happening is in France, we were not so used to have air conditioning in our house. And so it is something we have to be equipped. It is something which occurred today.
Yes. I want to follow on this discussion because, in fact, it's a lot more than that. Following the heat wave, government of France completely changed legislation and brought together major organizations from civil protection, Ministry of Health, Météo France, together to build a system called Vigilance, which really goes to the depth of département and ways of really preparing and anticipating. And this is why when you look at the next heat wave, now that model now has penetrated to entire Europe. And this is why I would say, going back to your comment, projecting these adaptation mechanisms that are proving over and over to be so effective in the projections are important. But that's brings me to my question, if I may. I would say science of climate is truly contributing to the international policy debate on climate change. However, we do experience extreme event and climate risk today, and next week, and next month, next season, next year. So if you can please comment from a scientific perspective on technologies on climate prediction on shorter timescales that could be really effective to support adaptation measures. And I would say your question is very spot on with whether, from a scientific point of view, where science is going and what technologies in different timescales seem to be promising. Thank you.
So just a brief example. We see now the beginning of an El Niño event. So all weather computation centers in the world are making forecasts. We know that there's, I think today, 80% probability of having an El Niño even next winter, and a 90% probability of having a strong El Niño this summer. And based on the known impact of ENSO on temperatures in different areas, but also on precipitation, this is a very useful seasonal information. It's not possible to, at the moment, to have earlier warning systems, but there's a potential for predictability on a time scale of several months to several years, and this relies on a better monitoring of the state of the ocean in depth, using modes of variability that are organized on this type of time scales. And even for Europe, there is a potential predictability in relationship to the state of the North Atlantic Ocean, potentially up to a scale of about 20 years, but it is still at the state of basic research at the moment. So that's the idea of climate services, in a way, which are being developed with the basic research, but also the whole spread of interaction with the rest of the society and the end users in order to identify the key variables that are at play for adapting. It's not mean temperature, it's sometimes temperature at a very specific time for agricultural activities or for the need for water, for energy. And this is something that's being developed called climate services in all the climate research centers, and in France it's the case at Météo France and also at Institut Pierre-Simon Laplace, where you can have contacts in this direction.
Sonia.
Yes, I also wanted to comment on this point. So as Valerie mentioned, there are some new developments with climate services. One point that we still have to keep in mind is some regions have better predictability than others. So for instance, the impact of the North Atlantic Oscillation is stronger in the winters than in the summer. So actually, for heat waves, I would say in Europe it's still a bit difficult. So at the moment, maybe at most you would have 1 month, but there is also some new research showing that you could possibly extend this window by taking into account, for instance, the impact of some moisture. And so there have been some developments also in France and, for instance, in Europe at the ECMWF, that's the European Center for Weather Forecasting. But it depends very much on the region. So, for instance, Europe is actually a bit more difficult than in some other regions in the summer.
Bonjour. I have a question for Professor Sonia. I was really amazed that what you mentioned here, what you mentioned about the biodiversity effects in afforestation projects that have not been considered in the negotiations, which means that there are a lot of red projects, if I understood well, that are not helping very well in the global, tackling global climate change. Which means also that methodologies that are being used are not considering the reflect, which is, I mean, there's a lot of millions that are being invested in red projects, funds that are being invested, and then you're telling us that maybe they are working in the wrong sense?
Okay.
I'm sorry, but I was like, how come this has not arrived to negotiation talks?
I'm surprised as well, but I think there was a most focus was on CO2, and we should say most of the red projects are in the tropics. So basically, where the afforestation does have a strong impact on CO2 and also doesn't really have this strong cooling effect. But personally, and I've discussed with people working in this area, they confirm it. So basically, it has not been considered so far because there is always this focus on CO2. While actually the net effect direct on temperature could be very strong, and that's, I can just say that's the state of the state of affairs, I guess.
I have just a question to Valérie. I mean, you affirmed that global warming seemed to have no effect on hurricanes. And you said it, sorry. And this seems counterintuitive, at least, in saying, everything moves but not hurricanes. And by the way, for my industry, hurricanes is certainly one of the most powerful, destructive powers. So how you explain that everything moves but hurricanes?
Yes, so there are some impact on hurricanes, but it has not been shown so far in observation. And so, for instance, one issue is that if you look at past climate, so you had a certain temperature at which you have a strong impact on hurricanes, but actually everything is changing. So you cannot find really a change in the past climate. There is also very strong fluctuation. In the projection, what is shown is that you would expect, so the frequency is projected to actually possibly decrease, but the intensity to increase and to have more heavy precipitation associated with hurricanes. But there is still large uncertainty, and the main reason is also that those events are not resolved by climate models. They're very small-scale events, very quick events. Maybe Valerie wants to comment.
So one limitation is the statistics that is available for hurricanes, and some of the trends that are seen in the last decades are linked to natural variability. If you look at 10, 20 years, sometimes you just see the imprint of natural modes of variability like in the Atlantic Ocean. That's a strong limitation for the conclusions. But as Sonia has said, it is expected to have 3 major impacts on the future extreme hurricane intensity. One is wind speed at the surface, expected to increase for the largest events. One is the heavy rainfall. And the third one is the impact of storm surges because of the interplay with sea level as well.
If I might just comment very briefly, it's different. There are 2 points, aren't there? There's having an effect and detecting an effect. And the point is the data are so noisy at this point, you can't detect an effect, whether there's one or not.
One more question here.
No, I was going, I mean, when Michel Carjon on the Warden School, I was going to reassure Dennis that you should be worried about hurricanes. I think what we do know is that the main drivers of what insurance and reinsurance companies are worried about is really the fact that more people, more assets are in harm's way. And you just alluded to it at the end. We don't know whether or not there will be more hurricanes. What we know almost for sure in that part of the world, in the US at least, is that the tail of the distribution will be becoming fatter. So more extreme Cat 5, Cat 3, Cat 4 hurricanes, which is really what you should be worried about if you do any business in that part of the world. I think the interesting part, if I may say, is that the scientists look at very different things than what the insurance industry will be looking at. They're not too concerned about the number of hurricanes hitting landfall, which is really what you care about. They're looking at what's happening in the ocean. So, an interesting debate. We don't have time to go there right now, but the noise, as I was mentioned, doesn't mean that there is no trend, just like we haven't been able to capture that.
Maybe just to mention, so there is a lot of background information on this in the IPCC special report on extreme and how to manage basically risk of extremes. And there, it was always shown that there is 3 dimensions to impacts. One is a hazard, the other one is vulnerability and exposure. And so, for instance, when you see this increase in damages that also Antoine was showing, part of this is also due to exposure or increase or vulnerability increase for some impacts. Yeah.
If one more question, I think we can go beyond the time frame.
Thank you. May I just ask a question in relation to the agricultural production and protein and the enormous cost, carbon cost of protein production? World population, 7.5 to 9 billion, and how we're going to feed them. You mentioned the point, but the alternative to cattle is going to be artificial protein, and therefore the investment in artificial protein to reduce the carbon cost. I'm not sure that's a question, it may be an observation, but I'd appreciate your view on it.
Antoine.
Well, I think you're fully right. And particularly there is some change in the diets in Asia. For instance, they want more and more, and it's quite understandable. They want more and more animal proteins, and that's a real source of concerns for both for of course for climate change also, but also there is something which will be difficult to maintain with 9 billion population on the Earth. So there is a real also again some innovative options to be worked on with regard with our diets and how to reduce our diets and keep fun in eating and also sustainability.
Maybe I can also comment on this point. 2 weeks ago, I was at a meeting from IPCC, which was on climate change and agriculture and food production. So it was a very big topic, and basically all different aspects related to food production and it's related to climate change were discussed. So so it was an expert team meeting, and the idea is possibly there could be a special report on this topic. I think one main issue is the demand from land. Actually, Jean-Tirole also mentioned it. The problem is that we have actually limited land, and some of this land is used for food production, some is used for recreational activities. Plus, you also now need to produce some energy, so biofuels, and so all those different demands basically are competing against one another.
Okay, I think we should conclude the session. May I just first, of course, thank the speakers, but also make a link between Jean-Tirole's presentation initially and some of the things which were presented now. Jean-Tirole stressed how difficult it was to control emissions, to set up systems to control emissions, and the problems that would raise to put in force any kind or almost of control on emissions. The interesting point from the presentations this morning is that we know that the emissions by various countries are very different between countries. We should add now that the consequences of warming will be extremely different between countries, with a negative, most of them, maybe positive for a few, but the fact that the emissions, the map of emissions is a one map, and the map of consequences of warming is a different one. That makes it even more difficult, maybe, to have any system in which controlling, because there will be very important external effects of what each country does in terms of the consequences of what they do. So let me thank again all the speakers, and I think we'll have plenty of time in the future sessions to explore some of the consequences of what they presented. Thank you.